So hello guys, welcome back. Today I will discuss some very good problems from the Allen score test series last year. So this is the first problem. Before I solve it out, you can actually pause the video and give it a try yourself. Okay, so I will start off now. So this is basically s equal to 1 squared by 1 into 3 plus 2 squared by 3 into 5. So I will write out the general term directly. So this is n squared divided by 1 into 3. So this thing is basically 1 into 3 and 3 into 5. This is basically 2n minus 1 into 2n plus 1. This is pretty obvious stuff. So now we have to, this will, as you can understand, this will come into a telescopic series. So we have to bring it into that form. So what I will do is I will divide this with a 1 by 4. Put one 4n square here, and after putting this 4n square, this step is to be noted. I will put this minus 1 plus 1 after putting the 4n square, not before it. So you guys might ask me that why didn't I put 4 and do this as minus 4 plus 4. I have done 4n square and then put the minus 1 and plus 1. Yeah, and this is divided by 2n minus 1 into 2n plus 1. So if we like split this thing, I will give an extra bracket. This is 4n square minus 1, so this is basically this product. So if we split these two terms, this will come out to be 1 by 4 whole multiplied by 1 plus 1 divided by 2n minus 1 into 2n plus 1. Now from here you can what you can do is you can find out s1, s2, s3, and there is another process for doing it. But what I will say is, because partial fractions is really important for your JEE mains, because nowadays partial fractions is being asked repeatedly in definite integration as well as indefinite. So I will try to do it using partial fractions. So what I will do is, although you can actually like split this using your observation as well, but I will do it using partial fractions so we have no confusions. I will take this to be a by 2n minus 1 plus b divided by 2n plus 1. So as per the standard method, first for once we put n equals to half and then we put n equals to minus half, ignoring this part. Because when we put n equals, because basically from here we get n equals to half and from here we get n equals to minus half. When we put n equals to half, we put it here, not here. Otherwise it will come out to be 0. So that's the method for partial fractions, you all know. So basically if you solve this out, you will have a equals to half. I'm not solving this, this is pretty easy, and b as minus half. So the final result is Tn equals to 1/4 of 1 plus half 1 by 2n minus 1 minus 1 by 2n plus 1. This is your Tn, and now this is into the proper form of a telescopic series. So basically we have to find Sn, which is nothing but sigma I from 1 to 500 Tn. So this is 1 by 4. This is okay. What I will do is I will not write this as 1 by 4. 1 is getting added 500 times, so this has become 500 by 4, and this is plus 1 by, I guess, 8. And now you will have 1. If we put 1, this will become 1 by 3, and again if we put n equals to 2, this will become plus 1 by 3. So basically these terms will all get cancelled. Now one direct trick that you can use, I guess you all know this. If you see that the first term for this pair, the first term for n equals to 1, or rather I equals to 1 is remaining, the first term. So basically for last term I equals to 500, this term will be remaining. So I'm directly writing this as 500 by 4 plus 1 by 8 into, this will directly, I guess, become 1 minus 1 by, you put 500 here, so what is 500 into 2, 1000 plus 1, 1001. So this becomes 500 by 4, and we have 1000 minus 1 is 1000 above, and below we have 8000. and 8. So this is basically it. Now we have been asked in the question to find out box of this particular value. So if you find out this thing, as you can obviously understand, this is some 0.00 something value, and if you divide 500 by 4, this will come out to be as 125 plus some value which is 0.00 something. So basically your box value for Sn will be 125. So in our question we were asked that box S will be less than. So obviously it's not 124, and BCD is 126, 128 and 130. So comparing, your answers to this question are B, C and D. So this was a pretty nice and simple question. We will proceed to the next question now. So here is the next question. So basically we have some mix of, I guess, vectors and integration. So first we will write out the data. We have modulus u equals to modulus v equals to 1, and we have u dot v as 0. So basically easy to understand that u and v, they are orthogonal vectors. I have written this as ortho. And we have been also given the scalar triple product, or rather the box product, uvw, given as 5 by 4. And we have been given another thing which is w dot u is minus 2 by 3 times w dot v. So basically we will go on to the integration later, because we need to find out w dot v and w dot u in some terms. So what I will do is, looking at the options C and D, obviously one of them has to be correct, or if it is not correct, even also the form will remain the same, otherwise they wouldn't have given. So I will try to take w, like this is just my assumption. Now let's see what happens. I will try to take it as lambda 1 u vector plus some lambda 2 v vector plus some lambda 3, say these are constants, lambda 1, lambda 2, lambda 3, these are all constants, as u cross v. Now first what I will do is, I will take the dot product of this particular thing with u cross v. So if we take the dot product, so w dot u cross v is basically the scalar triple product. So this side will come as 5 by 4. Now u dot u cross v is basically, as I will just explain, although you know this is dot product of u with a vector which is perpendicular to the planes of both u and v. So it's not lying in plane and perpendicular with u also. This is 0. Similarly with v also the dot product will be 0, and this thing is mod u cross v squared. And as mod u and mod v are 1, and we know that the angle between them is 90 degrees, so basically mod u cross v is also 1. This is pretty obvious. So we directly get lambda 3 as 5 by 4. And now it is given in both C and D, so we have to solve lambda 1 and lambda 2. We have no options. Now what I will do is, I will similarly take the dot products with u and dot products with v. So if I take the dot product with u, w dot u will come out to be as lambda 1 mod u square is simply 1, lambda 2 times u dot v is 0, plus lambda 3 times u dot u cross v is again 0. So this is lambda 1. Similarly, if you do w dot v, you will get this to be as lambda 2. Now we will use this relation, directly substituting. We will have lambda 1 as minus 2 by 3 lambda 2. So 3 lambda 1 plus 2 lambda 2 is 0. This is the equation we are getting. So now I guess it's time to move on to the integral. I will try to write out the integral once. So basically this was the integral given to us. This is minus 2 w dot u. This is minus 4 by 3 w dot v x cube plus 1 by x square plus 1 dx, given as pi by 2. So now what we will do is, we will basically use this relation, or take it a further step back also if we can. This is lambda 1 as minus 2 by 3 lambda 2. I am trying to do it basically in terms of lambda 1. So if we take minus 2 lambda 1, this will basically come as minus 2 lambda 1. because w dot u is lambda 1, and minus 4 by 3 w dot v from this equation you can, I guess, easily observe this is 2 lambda 1 x cube plus 1 by x squared plus 1 dx. So now it is pretty obvious this is the integral of some expression, some constant minus of some constant alpha to the constant plus alpha. So we can easily apply the, like we can multiply this by 2 from 0 to 2 lambda 1. And now as you guys know, x cube plus 1 is an odd function. So if you add the two areas on two sides, they will get like subtracted and this part will no longer remain. This is dx divided by x square plus 1. So this is a pretty, I guess, simple integral. This has been given, I will write it out here. This has been given to be pi by 2. So from here, tan inverse x squared plus 1 is tan inverse x, and tan inverse 2 lambda 1, 0 will become 0. This has become pi by 4, which is tan inverse 1. So lambda 1 becomes half. And from here, if we put this into this equation, lambda 2 is basically minus 3 by 2 into half, which is minus 3 by 4. So if we want to write down the final form of w, then this will become lambda 1, which is half u, lambda 2, which is minus 3 by 4v, and I will just take a look at lambda 3, this is 5 by 4, plus 5 by 4 u cross v, which you can observe is option number D. So our option D gets correct. C automatically gets wrong. And now in option A and B we have w dot w, which is basically mod w squared, and in one option we have mod w. So what I will do is, basically mod w is difficult to find from here. What I will do is I will try to find out mod w squared, and if we will try to see what that value comes and whether option A or B is correct. And for that we will do a pretty easy step. I will just take the dot product on both sides. So you will basically have half w dot u, which is half into half. That is actually the, I guess, the all the constants will appear two times. This is minus 3 by 4 into w dot v, which is again minus 3 by 4, and plus 5 by 4. Again this will become w dot u cross v, which is the scalar triple product. So again it is 5 by 4. So you can actually observe w dot w is nothing but lambda 1 squared plus lambda 2 squared plus lambda 3 squared. This is a pretty observing like inference from this part. So this we will get 1 by 4, this is 9 by 16, this is 25 by 16. So this is 1 by 4, this is 34 by 16, which on cancelling we will get 17 by 8. So basically on adding this, 2 gets to the top, 17 plus 2 is 9. So your final answer is 19 by 8, which is w dot w. So here our option B becomes correct and option A becomes wrong, because mod w squared is 19 by 8. So mod w should be root under 19 by 8 and not 7 by 4. So he is wrong. And for this question, the correct options are B and D. This was a good question. So now we will proceed to the next question. So this is the next question, and guys, please do try out the questions by pausing them. If I forget to tell you, please do pause and try out the questions yourself and then only see the solutions, because these are very good questions. So basically we have an equation in complex numbers, which is z power 9 minus 9 equal to 0. Okay, I'm actually sorry, this is not complex numbers basically, although you might assume, seeing z, that this might be a question from complex numbers, but this is not something like that. I will show you how. So what we will do is, as z1, z2, z3 are roots of this equation, we can write this out as z minus z1 into z minus z2 up till z minus z9, and this will become equal to z power 9 minus 9. So now what we will do is, because as you can see in the question, we have a very interesting sort of expression given, that is this particular thing, pi from I less j zi plus Zj. Basically, this is Z1 plus Z2 into Z2 plus Z3. That is the product of all these Z1, Z2, Z3 up till Z9. Rather, not the product. This is the product of the sum of pairwise two terms taken from all of these Z1, Z2 up till Z9. So basically, to bring out this term, what I will do is I will start introducing Z1, that is, I will actually start substituting Z1, Z2, Z3 in place of Z1 at a time. So I will show you with one thing. So here is the take. Now I had said one thing wrong. We will not take Z equal to plus Z1. We will actually substitute Z equal to minus Z1 and minus Z2. Otherwise, if you put Z1 here, this will actually turn out to be 0 because they are roots. So if we put minus Z1 and minus Z2, this is something of the form that is coming. Now you might wonder where minus 18 is coming from. Actually, what I did was Z power 9 from here is 9. And this is valid for all Z1, Z2, Z3, Z4. So I just substituted the value 9 here. And so this became minus 18. And we are basically just getting minus 2Z1, minus 2Z2 as we put all the values here. And rest of all these terms are actually, all of them are repeating. So if I have to, like, I have not written, this will go till minus 2 Z9 times this whole thing once again, and it is equal to minus 18. So now what we will do is we will just multiply all these, I mean up till minus 2 Z9, then this huge thing equal to minus 18. We will multiply all these 9 equations together. So we will basically get 18 power 9, and what you can do is you can actually cancel out the minus from each of these equations from the LHS and RHS. So we will first get 18 power 9. I'm writing the RHS, sorry, I wrote the RHS on this side, I had to write on this side, maybe, whatever. This is 18 power 9, and this is equals to 2 repeated 9 times, so 2 power 9. Now we have the product Z1, Z2, Z3 up till Z9. And after this, what we will have is actually this particular quantity that we were referring here. This is Zi plus Zj, and I should also put the limits here. This is less than equal to 9, and this is 1 less than equal to I. And this is the thing we are having. So basically, if you observe carefully in this particular part, I will write it out. I have to change the page. So this is our final result. All of these terms multiplying the product of the terms will be 9, which I guess is pretty obvious from here. I don't have to explain this because Z power 9 equal to 9. If we had the middle terms, we would take the sum 2 at a time, 3 at a time, but the last term is always, and as this power is odd, so the last term will be minus 1 power n and pi. Pi is basically all the products, all the roots product. So minus 1 power 9 will, okay, just a minute. I forgot to give a minus here, I'm sorry. This will also be a minus. So basically this is 9. This is pretty obvious stuff. I don't have to like blabber on this much. So this is 9, and this particular thing will actually come as a product 2 times if you observe this equation carefully. So this thing is lambda squared. If you write it out yourself, you will actually understand rather than my explaining. So basically this is 2 power 9, 2 into 9 power 9. So 2 power 9 gets cancelled. So lambda squared. If we actually take this 9 to this side, so lambda squared is basically 9 power 8. Now I guess we were to find the value of lambda squared by 9 power 7, which is basically 9. And now they had asked us which options are not the answer to this question. I guess this was it, or I will check once. Okay, I'm sorry, this was a single correct. So they had just asked the answer to this question. So the answer is B. So this was also a good question, manipulative question. We will proceed to the next question now. So here is the next question. This is, I guess, a pretty simple question on integrals. So what we will do is, this is a equals to integral 0 to infinity e power of minus z squared plus 1 by z squared dz. So what I will do is, this is very like a common type of question. I have to split the limits. I will split this from integral 0 to 1 e power of minus z square plus 1 by z square dz, and this will be integral 1 to infinity e power of minus z square plus 1 by z square dz. And now in this particular equation, not this, here if I take this to be some say integral I1, so basically in I1 I will substitute z as 1 by t. So dz will be minus dt by t square. So this will become integral 0. Okay, it's not 0 anymore. It's, I guess, 1 to infinity. 1, okay, it's not. I will just check once. This is, okay, it's 1 to infinity. 1 by t squared. Basically, it will become infinity to 1. I had taken the minus and I just split it up. Reverse the limits. You can do it in one extra step if you want. And this is e power minus t square plus 1 by t square dt plus integral 1 to infinity e power minus z square plus 1 by z square dz. So basically, purpose of splitting this and taking this was actually to make these two limits same. And now as it is variable irrespective, I will make and turn this also into x and this also into x, as variable doesn't matter. So this becomes integral 1 to infinity e power, okay, it's not e power, it's first 1 plus 1 by x square and e power minus x square plus 1 by x square dx. This is basically our final form, and now the question is done. We have to just make a small substitution, as is pretty obvious. You can see x square plus 1 by x square here and 1 plus 1 by x square here. So we have to substitute for x minus 1 by x as some u, so that when we differentiate this, this comes as 1 plus 1 by x square, and we can write this particular thing as x minus 1 by x whole squared plus 2. So this becomes 1 to infinity e power minus of u squared plus 2, as I said before, du. So we had to bring this, I guess, in terms of b. So if we write this as integral 1 to infinity e power minus u square, or as it is given y squared. Okay, this thing is 0. I'm sorry, I forgot to change it. If we write this as y squared as written in the question, y squared dy, and e power minus 2, which becomes 1 by e square. So basically this is b by e square, which is equal to a. So our a by b becomes 1 by e square. Basically, they have asked a by b is not equal to, so it is equal to c. So our options are a, b, and d. Although I don't know why they have asked this in single correct, but anyways, our correct options are a, b, and d. I will proceed to the next question. So here is our next question, and I guess this will be the final question for today. So I have, basically we have this particular function f of x, and as it's pretty obvious fx equal to k, so maybe we have to draw the graph or do something like that, we will see. So I will take fx at first at x less than equal to 0, because it is in a pretty complicated form, and x greater than 0 is pretty obvious. So this is equal to cos inverse of 1 plus x by root under 2 into 1 plus x square. Now to solve this, basically the first thing that should have struck your mind is this 1 plus x square, and seeing it you will be like very eager to make a substitution for x equals to tan theta, because you can see this will become secant squared theta, and this was 1 plus tan theta, and then you will have, this is a very like, this question is I guess also available in R.D. Sharma basics, so yeah. So this will become cos inverse 1 plus tan theta divided by root under 2 into 1 plus tan square theta is secant square theta. So we will have 1 sin theta by cos theta. So above it, this is cos inverse, I will put a bracket. this is cos theta plus sine theta, and now this thing will become by root 2, and 1 cos theta from here will go down. This secant theta, when it comes out of the root, this will go up as cos theta, so this and this will basically get cancelled. So this is our final f of x at x less than equal to 0. Now you can write this as cos inverse of 1 by root 2 cos theta plus sine theta. Now as we have cos inverse, so better to write cos of theta minus pi by 4. So this fx basically becomes, now as this is x less equals to 0, so this will open with a minus. I understand, I hope you can understand why I am doing this. This is minus of theta minus pi by 4, basically pi by 4 minus theta. Now theta from here is tan inverse x, so this is pi by 4 minus tan inverse x. So I will define the function once again freshly. This is f of x and it is equal to pi by 4 minus tan inverse x when x is less equal to 0, and it is tan inverse x when x is greater than 0. So now it is pretty obvious we have to actually find fx equal to k, and it is said that this will have exactly two real solutions. So they have also specified that this will have exactly two real solutions. So I guess we know the graph for tan inverse x, so we will directly try to do this from the graph. So here is our final graph. I have marked these curves as C1 and C2 so that you can have a clear understanding. This is pi by 4. And now we will look at the options once. It says A option says k can belong to pi by 2 to pi. So in between pi by 2 to pi, here is pi by 2 to pi. So basically I will draw this for you. So if you take y equals to k in between pi by 2 to pi, it will obviously have one solution because this is still pi by 2. So option A automatically becomes wrong. Now in case of option number B, it says k can be pi by 3, which is somewhere in between pi by 2 to pi by 4. So if this goes like this, yeah, it can obviously intersect these two curves and it has exactly two real solutions. So yeah, this option is correct. And for the next one, it says k can belong to pi by 4 to pi by 2, which is actually the same conclusion as this one. So this is also correct. And the final option says k can be 1. So basically, if we see the value of pi by 4, which is 3.14 by 4, it is 0. I guess if we calculate 0.7 something, and pi by 2 is 1.7 something. So basically 1 also lies somewhere in between this. If this is pi by 3, this is 1 point something. I guess this is 1.04. So 1 will lie somewhere here. So even in that particular case, this has two intersections and thus two real solutions. So D option is also correct. So basically the correct options to this question will be B, C and D. So yeah, that's it for today guys. I will bring in more questions in the next videos. And if you want the solutions to any particular book, famous book or anything else, or if you have any recommendations about my content that I should bring this out, then you can obviously write out in the comment section. So thanks a lot for watching, and do like, share and subscribe because it motivates me to keep going. Thanks a lot.